Hi guys, today what we're going to be doing is we're going to be learning about step functions. So this is another function that we need to be familiar with. And so we'll spend a little bit of time with. So these notes will also be very short because we'll do most of these problems together in class. I'm just going to give you just a little bit of an introduction for the notes. So starting with problem number 1, you rent a karaoke machine for 5 days. The rental company charges $50 for the first day and $25 for each additional day. Complete the table and graph the step function that represents the relationship between the number of days x and the total cost y. So what I'm going to go ahead and do is I'm going to remember that they charge $50 for the first day, $25 for each additional day. So this range, this interval that we have, 0 to 1, okay, so any time for that first day, okay, is $50. Okay, and then each additional day after that is going to be an extra $25. So 50 plus 25 is 75. 75 plus 25 is 100, then we get 125, and then we get 150. So, this is interesting. We filled in our y values before we worked with our x coordinates. So let's come back and talk about our x's. So this is 0 to 1, and so it means that, again, anytime during the day, let's say it's a normal work 8-hour day, if you pick it up, after they've been open for 2 hours, they're going to still charge you $50. And then your second day, so, once your first day starts, up until the very end of your second day. So that's, if you return it at noon, if you return it at 2:30, or you return it at 5, it's that cost of $75. So that's what the step function means, is it's talking about that range. And actually, you'll see this kind of range out in the real world so much more often than you have probably ever thought you would. So, but to finish up our intervals, we're going to have 3 is less than x. So the third day is less than or equal to the fourth day. So anywhere in between from the start of the third day to, or after the start of the third day until the exact fourth day starts. And then 4 is less than or equal to, 4 is less than x, which is less than or equal to 5. So let's go ahead and graph this. When we go ahead and graph this, it tells us up here that x is the number of days, y is your total cost. So let's make sure that we are labeling our axes if it's not labeled for us. And so I'm going to turn the page and write in my total cost. So when I graph this, I'm going to sneeze. I'm sorry. Excuse me. I'm so sorry. It's going to look like those compound inequalities where we have the open circle at 50, a closed circle at 1. So that was 50, 0, or 0, 50, sorry, and then 150. And then again, at 75, an open circle at 175, closed circle at 275. And then we're going to draw that line to represent that range. So again, our compound inequalities. And so we'll go ahead and keep doing this all the way up with our graph. So again, they talk about how, so these closed circles, another way to think about it is it's like the ceiling. It's the cap for each of those days. So anywhere from the start, they're open, 3 hours after they're open until they're closed that first day, and that sort of thing. But we'll talk about that some more next time I see you in class. Let's answer this question. Why does this function pass the vertical line test? So again, if we check the vertical line, we have open circle, closed circle. So really, no vertical line is passing through more than one point. Our points are represented by closed circles. Okay, so like I said, we're going to do most of these together in class. So let's skip 2, 3, 4, and we're going to go all the way to number 5. So number 5 is actually a review problem that I want us to make sure that we do. So as Erica is driving her car, she notices that after 1 hour, her gas tank has 7.25 gallons left, and after 4 hours of driving, it has 3.5 gallons of gas left in it. On average, how fast is Erica's car using gas? So real quick, what I'm going to do is I'm going to be labeling the variables. I'm going to label what x equals, what y equals. X is going to be whenever there's time involved, that's what x is. So it's my number of hours, so y has to be my total gallons. Then I'm going to write down my ordered pairs. So after 1 hour, it's 7.25. After 4 hours, we have 3.5. Okay? Then, when they're talking about how fast, they're talking about rate of change. So this is a rate of change problem. Rate of change, one way to find it, you use slope, the slope formula. So I'm going to take my y coordinates, subtract them, so the change of y over the change of x. So that's going to be 7.25 minus 3.5 over 1 minus 4. Make sure you keep your ordered pairs lined up. When I subtract, I get 3 3/4 over negative 3, which simplifies to negative 1.25. Okay? To put this into words, because this is a story problem, she uses 1.25 gallons per hour. That's what this means that we just found. Now part B says, assuming the relationship between H and G is linear, find an equation for G in terms of H. So when they're talking about linear, we're going to think about all the different equations that we use with linear. Well, one of the equations we use is y equals mx plus b. Okay? So, but really in this case, we're using H and G, so it's going to be G is equal to mh plus b. Now using the information from the problem before, we know our slope, we don't know our b, so that's what we have to find. So we're going to just pick one of your ordered pairs. I'm going to pick the second one. It really doesn't matter, but I'm going to put 3.5 in for y. I'm going to put negative 1.25 in for my slope, and then 4 in for x. Okay, and then I just solve for b. Okay, so again, it was just an ordered pair that I put in. Doesn't matter which one you pick. I just chose one, and we know our slope. So when I multiply this together, I get negative 5. I add 5 to both sides. I get 8.5 is equal to b. Now my last step is to write this equation, again in terms of g. My slope, negative 1.25. H for the variable plus 8.5. Okay, that's it for these notes and for this review problem. I will see you guys next time in class.